So I went ahead and ran this simulation here. This one I launched on March 12, 2016. It took me a while to manipulate some of these because this is really all you can change. You can only change not only the planets that they're leaving from and their destination, but it also changes the launch date to where the satellite could be successfully passing from one orbit to another. Let me go back and set the parameters for this. Earth and our destination here, first of all, will be Venus. So I kept the data as March 12, 2016. Now, of course, there's probably other dates you can use, but this one, as you run the simulation, if you send a probe or satellite, I believe when I wrote it down, this date works well with Earth and Mars. So if I launch it this day, March 12, 2016, and I rendezvous the satellite with Mars and its orbit, we're focusing our efforts now more on how gravity affects things that are on an incline. So this is our first lesson for here. Every object has a center of gravity. The center of gravity is where your entire weight of your object may be concentrated in the middle to kind of balance everything else, if you will. If you support things at this point, the body remains at equilibrium at this position. So it's right in balance with everything else around it. Here's an example showing you this. The picture on the left kind of shows it from what the words explaining on the right. So take, for example, you have a 12-inch ruler or a 1-foot ruler. Now the center of gravity in between 1 and 12 inches is going to be right in the middle, which is the 6-inch mark. So if you had your finger on that center of gravity and held it there, then you would be able to balance that ruler and not let it fall to either the right side or the left side. It would be perfectly suspended, as you see in the picture here, showing you that it's met in the middle between 1 and 12 inches. Now, your object's weight, what in physics we define as the capital letter W, it's shown to you here and it's represented by a vector. So once again, it's going to have a magnitude of value, and it's also going to have a direction, as you see here. In this case, because the weight is affected by the force of gravity, it's going to be directed downward along that line as if your object was just dropped straight down. So even though it's on an incline, as you see, that incline is not going to affect it as far as our weight is concerned. Our weight is always pulling straight down, so it's always going to be perpendicular no matter what the angle is of our ramp or our incline. It's always going to be perpendicular to the ground as it pulls downward on its object. Now, if an object is at rest, not sliding on your inclined plane, the weight is going to be what we consider to be equal to the normal force. So it's perpendicular to the surface and it's equal to our normal force, as long as, of course, the force keeping the object from falling through the table. So in this case, as you see here, if it was a normal case and the incline wasn't there, then gravity will pull it straight downward. But of course, it's at that angle compared to what the normal would be pointing upward from the object. So you can see it makes certain kind of angles that you can calculate for to see exactly what your values are when you have weight or friction or the normal force applied to it. To solve this one, you know that weight is equivalent to mass times gravity. So if you rearrange this formula, mass is equivalent to the weight divided by gravity. So if you know the weight of your box is 300 newtons, and you know that the force of gravity is always 9.81 meters per second squared, when you divide these two out, you can get the mass actually of your box, not the force acting on the box, which is your weight, which is a vector, but you can actually figure out what's the mass of the box just by knowing these values here. So when you solve for this one, you should get 30.6 kilograms as the mass of your object. Just divide the weight, which is the force 300 newtons, divided by the force of gravity, which is an acceleration, and you should get 30.6 kilograms for the weight. Now, the reason why you need that is because for that, you can use this simple equation that we covered for force. Force is equivalent to mass times acceleration. So the force parallel is no different from the force. That is also the same thing as mass times acceleration. With only the forces mentioned on this diagram, only the ones shown here, don't include any other forces here, only the ones you see here. Can a car drive on a bank turn at a 90-degree angle? So this would have to be a 90-degree angle. And of course, we can't go any higher than this.